Hello and welcome back to another lecture. In this lecture, we're going to go ahead and do some truss analysis. I got my helper right here helping me out. When we look at the truss, there's a few assumptions or a few rules that we have to follow. Number one, the entire truss is a rigid body. If the truss is rigid body, that means there is the equation of equilibrium, which also the summation of moment equals 0 will apply. But we say since this is in equilibrium, therefore each joint also is in equilibrium, but each joints are pinned. Pin means basically a shear connection, so you have a two restriction, so summation fx is equal 0, and summation fy is also equal 0. All members are straight, and there are a number of ways we can connect these, which I have on a screen. One of them is a gusset plate, which I already have done an example. You can see the link down below, and using latest ASC addition. But to analyze this, each member either are in tension or in compression. We're going to go ahead and calculate those member. And how we're going to do that? First, we're going to go ahead and use two different methods. One is method of a joint, and the other one is method of a section. In method of the joint, first we're going to go ahead and calculate the reaction, and then we take each joint and we analyze it. It's very easy, a piece of cake. So let's go to work and take care of this one. We're going to go ahead and take a moment. This is basically one reaction right here. It's a roller. And in here we have two reactions, AY and AX, and this is going to be BY. I'm going to go ahead and take a moment about point D. Summation moment about point D is equal 0. This is for entire truss. Going counterclockwise is positive. So I'm going to start from this end, and that's going to be clockwise. It's going to be minus AY times 888. That's 24, 3 of them. And then I have nothing else until I get to the 2 kips, and 2 is going to go ahead and rotate counterclockwise. So it's plus 2 times 16. That's the distance from here to there. And then I got plus 2 times 8. That's this one from to here. And this cannot take a moment bar in here because it's in the same line of action. And that's going to equal 2, 0, and therefore AY is going to come out to be. So now at the same area, we're going to do summation f of x going right is positive is equal 0. I have no x value here, so AX comes out to be 0. AX is equal 0. And if I do summation Fy for the entire body, it'd be summation Fy is equal 0. Going up is positive. I have, this was 2 going up, minus 2. Minus 2 minus 1.5 plus by is equal 0, and by comes out to be 2 cancel each other out, it'll be 3.5. And that's a positive going up. All right, so we're going to take a look at the joint A. This is A. I have AX, which is 0. And then I had AY, and that came out to 2 kips. One of the things is always assume, if you don't know whether this member is in tension or in compression, always assume it's in tension. But if you know, that's easy. And as a rule of thumb, always bottom member, in cases like this, bottom member are in tension, top member in compression. So I'm going to use that rule. It says this is in tension, so the tension is going to go away, and that's going to be F of AB. And then I have F of AH coming in the compression, so it's going to show it like this. F of AH, it's in compression. But one of the things is I got to find out what is the direction of this, either the angle or the direction. Sometimes they give you the angle, sometimes they don't. So let's take a look at this member right here. I'm going to blow it up right here. You have, this is a 4, these are all same line. So this is a 4, and this is a 8. So you got something like that is a 4, 8. If I divide this by 4, that become 1. If I divide this by 4, that become 2. So now I have a triangle like this, 1, 2, and if I use Pythagorean theorem, 1 square plus 2 square become 5 and square root of 5. Remember Pythagorean theorem, it's on the board. So that's the square root of 5. Then I'm going to come in and show it like this, 1, 2, square root of 5. Okay, so now I'm going to go ahead and try to calculate the, using these two only equation applied to each joint. If I use summation f of x, I got 1 unknown, 2 unknown, I cannot do it. But if I use summation f of y, I have 1 known, 1 unknown, that will work. So I'm going to go ahead and summation f of y is equal 0. Going up is positive. I have 2. And then for here, to get the y direction of that, it's going to be the y direction is a y. Remember 1 divided by square root of 5. So that's going to be minus 1 divided by square root of 5 times f of ah. And that will be the vertical portion of this force. Because this force will have, if I continue this force, has a vertical portion and has a horizontal portion. And that's it. There's nothing else. Is equal to 0. And therefore, f of ah comes out to be 4.47 kips. Now I'm going to go ahead and do summation f of x is equal to 0. Going right is positive. I have f of ab, and then I have minus f of ah came out to be 447, but the horizontal portion of it is going to be 2 divided by square root of 5 times 2 divided by square root of 5 equals 0, and f of ab comes out to be 4 kip. And that is in tension, and this is in compression. Okay? Now remember, because I assumed correctly and my number came out positive, that means I assumed tension was positive. And if I assume compression over here and my number came out correctly positive, that means my assumption was correct. However, if I had this going up the other way, and this number would have came out as a negative number, then I would have known that is I made the wrong assumption, then I have to correct it. All right, let's do another joint. Let's pick another one. So now we know this, then you can move up here. This is really easy because you got a 0 member here. Let's take a look at this one. So I got joint B right here. This is B. And again, we said these are in tension, bottom member. So I got one going this way and one going this way. And then I have this member. You can make it either way. Make it compression, make it tension, doesn't matter. If you don't know anything, just say call it tension. So when you have this right here, this is f of AB. We already know that, which came out to be 4 kips. And this is f of BC. And then this is f of BH. All right? Summation f of x is equal 0. There's only 2. So these two are equal. This will come out to 4. And that's based on summation f of x. Summation f of y is equal to 0 here. Going up is positive. There's nothing. There's nothing. So b f of BH is equal to 0. That's a 0 member. That was easy to do. Now you can take that and put it over here. Let's do this one, and then you can do the rest of them yourself. All right, we're going to do this joint right here. This is a really difficult joint to do. So let's go ahead and put it in. I got this right here. We have member AH coming in, GH coming in. Those are compression. We got 2 kips coming in. We got the 0 member. And then we have this other member coming in. Let's say it's all compression. It's coming in at this angle. I don't know what angle is it. I have no clue. And now we have f of HC FHC. So now we have those, and you can't really do, if you do Cartesian coordinate, there's no way you can solve it because you have too many unknowns. So best is to make this axis right here, x, and then do a 90-degree to it as a y, which be this one right here, y, and we have to figure these angles out. So to figure the angles out, I gotta figure this angle out right here between vertical and x, and also between x and f of hg. So I'm gonna come back, and I did this before. I gotta look at this right here, this section. I'm gonna find out tangent of theta, which is basically opposite divided by adjacent, and tangent theta is equal to 4 over 8. Theta become 25.56. So this is 25.56, and this become 90 minus that, it can become 63.43. So this becomes 63.43. And then now, this right here from the this angle from here, this angle from this angle right there is basically, if this was a 26, if I come in, bring this down here, it become like this, 26 point, whatever it became, 26.56. That's a 20.56. So this is 26.56, and therefore from here to here be 2 times 26.56, and that is 53.13. Whew. That's not easy. So now we got that, we can go ahead and calculate it and solve it. Let's finish this one up. And now I can go, okay, summation of f of y is equal 0, and y is going this way, positive. So now I'm going to have f of hc. So that's going to be positive way, sine 53.15 minus, I'm going to bring it underneath. Let me just bring it over here. F of hc sine 53.15, that's 1. And then these, they don't count, they're the x, so the only thing I have is a 2. And 2 is going to be sine 63. And 2 is going to be opposite, so it's going to be minus 2 sine 63.43. I think I got them all. That's it. Equal 0. So f of hc is equal 2.24. We assume it was compression. Our number came out positive, so it's compression. There. Now I can go ahead and calculate this other one. Summation of f of x is equal 0. Going this way is positive right there. And then I have 447, and then that has to have the 2. It's going to be that way, so it's going to be minus 2 cosine 63.43. And then I have this one. It's going to be the opposite. It's going to be minus also, minus 224 cosine 53.13 equals 0. And then I got minus f of h minus f of gh equals 0, and f of gh is equal, that's also 2.24, and we made a correct compression. So you notice, so when we do summation, when we do a method of a joint, sometimes some of them are easy, but sometimes we get to a point like that, it's really difficult. then you have to kind of use some geometry to solve it. This was a method of joint. Next, we're going to go ahead and do another problem using method of a section. Let me erase this board, and we're going to use method of a section to solve these. Basically, this, if I do a free body diagram, I have two forces here, right there, AX and AY, and then I have a EY. And take a look what I have on the board. Method of a section, basically, you go ahead and do an imaginary line between the trusses, and in that way, you have two separate trusses, and replace where you make the cut. You replace them with the internal forces, so you got two rigid body, so all the equation of the three equation apply. Summation f of x is equal 0, summation f of y is equal 0, and summation moment also is equal 0 in those three equilibrium equation. So let's go ahead and solve this. Look for one of the question is what's the member f of BH is equal what? So let's just cut it right here. And if I cut it right there, I'm going to come back in here and redraw that in here so we can see a little bit better. We got this, and then we got this member right there. We have right there connected to here, and then we connected it, ripped it on this side. So because I'm going to replace them with the force, top core or compression, let's just say assume everything is in tension to make it easier on the drawing. So I'm going to go like this, and that came to here, and then I have this member going like this, and then it's going to go all the way here, and then I have this member also coming this way, and it's going to go here, and this will be point H, and this will be point C. Right here we had 4 kips, and here we have 2 kips, and here, oh, we got to figure this out. So let's figure this out quickly. I'm going to take a moment about E. Summation moment about point E is equal 0, counterclockwise is positive. And I'm going to have AY, it's going to be negative, minus AY times 24. I have nothing else. This, oh, plus. Then that's going to be plus 2 times 24, plus 4 times 18, plus 4 times 12, and plus 4 times 6. Equals 0, there's nothing else. And x cannot do it, it's on the same line of action. So AY comes out to be eight kips, so that's 8 kips. Now what I gotta do, I gotta take a look at this and look at this as a rigid body. And this is a point B right here. Remember, if I take a moment about point B, I don't know this force. This force is that's a F of BH, F of BH, and this one is a F of BC, and this one is a F of GH. So take a moment bar here, you automatically eliminate this, so you only have one unknown left. And you have all these forces. So let's come up here. Let me change color, see if I can, this shows up better. Summation moment about going counterclockwise is positive about point B is equal 0. I have 8, that's 6 feet right here. So it's going to be 8 times 6 is negative, minus 8 times 6. And then I have up here, I have plus 2 times 6. And this cannot take a moment on the same line of action. This cannot do it, so I got this. And that's going to go negative minus f of GH time, we said that was 3 feet. 3 feet and equals 0. So now I'm going to have f of GH is equal, it's equal minus 36 divided by 3. Which is equal minus 12 kip. So this is really good. I assumed this was tension. Remember at the beginning I said always top chord is a compression, so that should have been compression, but we said we didn't know that, so we made a tension. Because I made a wrong assumption, this number came out wrong. So it's not tension, it's in compression. That means this is equal 12 kip in compression. So really this should have been like this. If I did it right, it should have been like that. So that's in compression. Now we have that, and we can go ahead and calculate it. The way I can do it now, I can take a moment about point H. That's going to eliminate this, and it's going to eliminate this. So let's take a moment about point H. Going counterclockwise is positive. Marker is not. So I got to have 8. That's going to be negative minus 8 times, that's going to be 12. And then I'm going to have plus 2 times 12. And then plus 4 times 6. Okay. And this can't take a there, and that can't take it, and all I have is f of BC, and f of BC is going to be plus f of BC times 3 equals 0. So now I'm going to have f of BC is equal (8 times 16 kip), and assumed there was tension. Number came out positive. So it's in tension, that's correct. And all is left is this one, so we can go ahead and basically do summation fx or summation fy, it doesn't matter. And you can solve that. If I do summation f of x is equal 0, going right is positive. I have nothing, 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 so we'll stay with that. And that's going to be 16 kip. And then I have nothing here. And so this is how it's done. And I hope this was useful. If you like it, give it a thumbs up. Thank you.